From any data source, the type of data that we get can range from structured to unstructured. Structured data is where you know the schema. That is, you know exactly what kind of information is going to be there. The fields are defined, the types are defined, and there is no ambiguity or uncertainty around it. A classic example would be a table from a database. On the other hand, unstructured data is where you know practically nothing about the kind of input. An example would be a photo or a piece of text, which could contain literally anything, and you certainly don't know the types, and you don't even know whether it follows any kind of predefined order or what we call a schema. This, however, is not a binary classification. Datasets are not either structured or unstructured, but rather lie on a continuum from structured to unstructured. And you could even put in a third bucket called semi-structured. An example of that might be a JSON file. It does have fields and they do have values, but it's not like there are predefined fields or they only necessarily need to have a specific value. It is possible to take unstructured data and convert it to structured data, which makes it easier to analyze. And a significant portion of the data extraction work that people do involves converting unstructured to structured data. But keep in mind that you could get data ranging anywhere from fully structured to fully unstructured when you look for data from any data source. One example of structured data is the kind of data that you will find in databases. Here is an example of a database table. This is a census PCA table that has, for each state, district, subdistrict, town, ward, etc., details about the population and several other pieces of information that is typically available as part of the census. Now, this follows a schema, that is a defined structure. There is a state, which is always an integer. There is a district that is always an integer, a sub-district that is always real, and so on. And there is a level that is text, there is a name that is text. So effectively, you know not just what are the columns in the data, but also the type of or the values in this. In fact, it is possible to have an even more narrowly and closely defined structure that says that the state can only have a number between 0 and 50, the subdistrict can only have a number between 0 and 500, and the level can only be a piece of text that has 2 characters, and so on. These are ways in which you narrowly define the structure of a data set. Schemas also make it possible to have interrelationships. So, for example, here is a database that contains multiple tables. And these tables contain information that could be interrelated. For example, this Twitter table has details about what keywords were mentioned in Twitter that are part of a certain subcategory within a category in a quarter on a certain date. And the quarter column here may be the same as the quarter column in the sales table or the reach table, and so on. The categories and subcategories may be the same across all of these. And with this information, it becomes possible to join data across multiple data sets. This is one very powerful characteristic of structured data sets. Another example of structured data sources are spreadsheets. In a spreadsheet, quite often, you can put in data that is reasonably structured, like a table where you have specific columns, and each column can have a response that's more or less well defined. So it can only contain a specific set of values that may be predefined text, or it may only contain specific numbers. However, a spreadsheet is not necessarily used only for structured data. It certainly is possible to put in other kinds of data into a spreadsheet. So it's important to remember that structured data can be in spreadsheets, but spreadsheets are not always structured data. Just like databases support multiple tables, spreadsheets support multiple worksheets. And it's possible to join many of these by linking them together and create the equivalent of joins that you have in databases. A third example of structured data comes from shapefiles. Shapefiles contain geographic data about locations. For example, on gadm.org, you could look at the maps for each country. Let's say we go into Afghanistan and then dive into specific divisions and subdivisions and look at the maps for each of these districts. It's also possible to download this data for each country. And when we get the data for Afghanistan as, let's say, a shapefile, The dataset is a collection of files that has information about, for example, what the shape looks like. That is what you would find in a .shp file. This is what an SHP file looks like, for example. And you will also find associated information about it in a DBF file, which is like an Excel file. And this is what the associated DBF file for Afghanistan looks like. It has details about the country, the state, the district, and a few other pieces of information about that particular district. So a shapefile is actually a complex structure that contains spatial information as well as tabular information packaged into a single container. Semi-structured data, again, can have a variety of forms. One example of semi-structured data could be found in documents. For example, a PDF file or a HTML file. Let's take a look at this PDF file. It contains multiple tables, and each of these tables contains different kind of information. But you will notice that as a document in itself, its structure is firstly a little more complex, and it's not entirely tabular. So it may be possible to extract a schema from this, but it's certainly not stored in a way that the schema is easily extractable or even intuitive. So at the very least, we could say that it's semi-structured because we have to figure out what the structure is, and we don't know whether it's fully structured or not, but it certainly looks at a first glance to be structured. Or take this Wikipedia page that contains information about world population. There are pieces of information here that are structured, and there are pieces of information here that are not structured. And it's a container that has a combination of this information, which makes a web page such as that of the Wikipedia world population page a semi-structured document. Another example of semi-structured data can be found in messages such as email or SMS. Here's a simple email message, which perhaps is a spam message. But behind the scenes, if you look at the original, then that information has details about the message ID, where it was created at, what was the subject, who it was sent to. And all of this is in a fairly structured format, but it also contains information that is unstructured, such as the text, such as the attachment that came along with it, and some of the information that's part of the headers. They too can be unstructured. So it's a combination of structured and unstructured data that makes messages like emails semi-structured. In fact, one of the places where you can consistently find semi-structured data is in container formats. When I say container format, it's a file format or a structure that can contain other pieces of information which may or may not be structured. Zip files are a good example. You can have a highly structured spreadsheet along with it a fairly unstructured text file that explains what that document is about. Or even a docx or a pptx or an xlsx format. This inside a docx, you could have text, you could have a table, and you could have an image, some of which are structured, some of which are unstructured. Whenever you see containers that contain multiple pieces of information, then it's a reasonably good hint that it's probably semi-structured, that it's a combination of structured or unstructured, or is partly structured and you don't necessarily know the schema. Unstructured data sets are where you know little or nothing about the contents other than a broad idea of how to parse the content. For example, that could include text, that could include images, audio, video, and within this, so let's say we are looking at an audio file, you may be able to extract information such as its length. You may be able to identify what is the average volume in this. But beyond that, getting any kind of meaningful information out of something like audio is not that easy, at least for a system. For a human, it's reasonably easy to listen to it and understand what is being said. But for a system to do that, that takes a little more effort. Increasingly, a big field of work is focused on extracting structured information out of unstructured data. Many of the techniques in deep learning are really focused on, for example, can we take video imagery and find out who are the people that are in the video footage, or what are they saying, or where are they located, or are there two people that look similar? These are examples of the kinds of structured information that people are extracting from such unstructured data. But by and large, unstructured data, until it gets converted into something that is structured, is really hard to analyze and do any kind of processing on.